Okay, we will continue a little bit more on the special angles. Okay, now previously we saw the three types of graph. It's the graph of sine, the graph of cosine, and this is your graph of tangent. Okay, now, and we also saw this previously. Okay, the three angles, the three angles which are special angles, 30, 60 and 45 degrees. So we actually use these two triangles to define the ratio of the angles. Okay, there are a few more angles that we can actually determine the value from the graphs. Okay, this is also considered angles which I think we can actually look for the value from the graph itself. Okay, so let's say we take the graph of sine. Okay, this is your graph of sine. Right? So when you're actually looking at the graph of sine, you realize that the pattern here is the graph starts from 0. Okay, it goes up to 90 degrees, comes back to 180, 270 and 360 degrees. So from here we can actually determine the values of sine. At 0 degrees, here the value is 1. At 90 degrees here, sorry, at 0 degrees, sorry, this is 0. So at 90 degrees it's 1. At 180 degrees it is 0. 270 degrees is actually a -1. The reading is here. And at 360 degrees it is 0. So the graph is 0, 1, 0, -1 and 0. Okay, now likewise for the graph of cos. Okay, the graph of cos. So the graph starts at 1. So that means at 0 degrees, the value of cos is 1. 90 degrees, you see it comes down here. This is 0. At 180 degrees, it comes down further, a -1. Here, this is a -1. At 270 degrees, it goes up again. So it becomes a 0. From -1 to 0. And at 360, it goes further up. Value is 1. So I repeat again, the amplitude for both these graphs, the sine graph and the cos graph, the amplitude is 1. Okay, now we look at the tangent, the graph of tangent. Okay, for the graph of tangent, there are a few things we can actually look at. Okay, now there are a few asymptotes. So we start with 0. 0 degrees, tangent of 0 is 0. At 90 degrees, it's undefined. Okay, and then at 180 degrees, it comes back to 0. At 270 degrees, it's undefined again. Okay, and 360 degrees, it comes back to 0. Okay, so these are some of the values that you can actually obtain from the graph itself. Alright, so if you actually remember the shape of the graphs, determined from that without using the calculator. Okay, now there are a few more questions that we have seen. This one, example like this. Let's say the question says without the use of calculator, find the value of sine 45 degrees. So if this is without, we got to use the triangle given, the special triangles. So sine of 45 degrees. So sine of 45 degrees is 1 over square root of 2. Okay, all right. Okay, Now we go for cosecant 45 degrees. So if you remember, cosecant is actually 1 over sine. Okay, cosecant is actually 1 over sine. So if this is 45, this is 45 here. So this becomes 1 over square root of 2, which actually gives me square root of 2. Okay, so for now, I'll just leave the answers in certs. Alright, I'm not evaluating it in decimals. Okay, now we go for tangent 30. Tangent 30, this is again your special angle. Alright, so tangent 30 is square root of 3. Sorry, tangent 30. Yeah? This is tangent 30. So tangent 30 is here. Tangent 30 is 1 over square root of 3. Okay, so if we're talking about cotangent 30, cotangent is 1 over tangent 30 degrees. So tangent 30 is what we got up here just now. This is 1 over root of 3. Yeah? So, okay, so this becomes square root of 3. Alright? Okay, next is, let's say I've got secant 30 degrees. So secant is actually 1 over cos. So 30 degrees, so this is also 30 degrees. So cos of 30, we found earlier, cos of 30 is square root of 3 over 2. So this is 1 over square root of 3 over 2. So when you change this, this becomes 2 square root of 3. Because you cannot leave your answers like this. Huh? So what we do is we multiply this by square root of 3, by square root of 3. So we get 2 square root of 3 over 3. Okay. So this is, let's say we were to ask to calculate without using calculators. Okay. Alright. So just a few more examples, something that you have seen before. Okay, let's say we need to calculate these angles. 100, sine of 120 degrees. Okay, so now this is not an acute angle, this is an obtuse angle. Okay, so here we are actually going to look at the quadrants that we have seen earlier. So we sketch out first 120 degrees. So 120 degrees actually fall in my second quadrant. Okay, so if it's 120, if I'm going to do it without calculator, I need to get my reference angle. So to get your reference angle, 0, 90, this is 180. So I'll actually get my angle here. So it's 180 minus 120. This is actually 60 degrees. Okay, meaning this angle now, 120 is equivalent to this angle of 60. Yeah? So I put it down here. So this is actually equal to sine of 60 degrees. And sine being in the second quadrant, your sine is positive. So sine of 60 degrees will become square root of 3 over 2. And it's positive because sine is in the second quadrant. Alright? Okay, next one. Let's say we go for cos of 210. Okay, so 0, 90, 180. So I want 210 means if you're going to measure from here 0 all the way up to 210. So this is 210. And again, this is not an acute angle. So I'm going to look for my reference angle. So this is 210, subtract 180. So I'll get 30 degrees here. Meaning this is actually equivalent to cos 30 degrees. Okay, now this is in my third quadrant. So cos in the third quadrant is actually negative. Okay, so this becomes negative if it's cos 30 degrees. This is actually square root of 3 over 2. Okay, so this is all without calculators. Okay, next one, let's say we go for tangent 300. Tangent 300 degrees, again, if you were to draw 0, 90, 180, 270. So 300 is a little bit more than 270. Alright, so what you'll actually get is here, this angle, reference angle, which is actually 60. So this is actually 360 degrees minus your 300, so you'll actually get 60 degrees here. Okay, so this is equivalent to tangent 60 degrees. Now this is my fourth quadrant. In my fourth quadrant, tangent is actually negative. So we add on a negative. So tangent 60 negative, this is negative square root of 3. Alright? Okay, so these are some of the questions which can be solved without using calculators.